Hi, grade 10. Hope you are fine and everything is good. Sorry for being late in uploading this video, but it was the vacation. Anyway, we have done with the chemical formulas, names and formulas 7.1, balancing chemical equation. I have uploaded an online tutor video with a support worksheet because balancing mainly is practicing. As more as you will practice, you will be more fluent in doing balancing for chemical equation. The only thing I wanted to rehearse here to highlight its importance that you in the chemical in balancing chemical equation you are changing the coefficients and not the subscripts. Don't forget that. And now finally the last thing or lesson or objective in our term is the types of chemical reactions. And here I want also to mention to not forget that those videos, their vision is not a substitute to your textbook or your notes that we are like for 3 months now we are covering them. Sure, not that videos or which for 15 minutes or something will substitute it. So to get the full mark, please don't miss your notes or the textbook, especially the word equations. We will practice more on Sunday and Monday, but converting word equations to formula equation, because I think this is the part that we didn't practice a lot about them, and I can say that it is a type of a high achiever question that would be in the exam. Sure, it will be in the exam. The last thing here, let's say the types of chemical reactions. As you know, there are 5 types of chemical reactions. And let's start by the easiest thing, which is the combustion, single displacement, where we use the activity series table, and double displacement. And last, the synthesis, which is opposite to the decomposition. Synthesis and decomposition have a little bit information to memorize, but the good news is that they are opposite to each other. Yani just when you memorize or study one of them, this means that you studied the other. So let's start by decomposition, or sorry, by combustion. No, I was not planning to start by this, but okay. Double displacement. Okay, when I say double displacement, that means, as I said before, displacement, that someone take the place of another one. So here, double displacement, there are 2 things that they took the place of 2 other things. So here the simplest thing that you will do, that you will find that the cation will take the place of the other cation, and the anion will take the place of the other cation. Okay, so you will find yourself that you are only switching them. So it will be the potassium with the nitrate and the lead with the iodide. So it will be the potassium with the nitrate and the lead with the iodide. Here we will go back to back here. The next step, as you know what we are doing, that we double check if we wrote the chemical formula right. So here at your draft, as I told you what to do, here you will get the potassium nitrate first, potassium and nitrate. Nitrate is a polyatomic ion that has -1, potassium is +1, so we don't write the ones, so it will be potassium nitrate like that, which is that one. Lead iodide, lead is +2 and I is -1. Miss, how I know that the lead is +2? Because here it's 2, right? This 2 is for whom? For whom this 2? Is for the lead. We are crossing over, right? So this 2 is for the lead. So +2 and the iodide is -1, as it is in group 17, and also it's clear here that it is 1 because the potassium nothing to be written here. So, and then by crossing over, the lead will have the 1 and the iodide will have the 2 oxidation number of lead. So it's potassium iodide. Next step, to balance it, And here you will find yourself that you need how many iodide? 2. At this case here you had 2 potassium on that side and 1 potassium here, so you will write 2 here. At meanwhile you multiplied not only the potassium but also the nitrate, but here you have 2, so now it is also balanced. This is the double displacement. Okay, so what happened here, that the cation took the place of the other cation and the anion took the other place of the another anion. Here there is a very tricky point I want you to take care of and be cautious when you find it. When you have any oxide, when you have any metal oxide, like here when you see if the question was complete the following reaction. So you will say, okay, it's simple here. I have 2 compounds, so it is double displacement. Here, as I told you before, that you will write the water as HOH. So the calcium will take place of H and the OH will take place of take place of the OH. No, this is not the case here. Why it's not the case here? We will take it in the synthesis in details, but for now, in a moment I will explain it. For now, I want you to be very cautious. Once you found that the compound in front of you is oxide, so it is synthesis and it is not double displacement. Clear? Okay, so let's go to the next type, combustion. Combustion, it is the easiest one. Why it is the easiest one? Because simply once you have carbon, hydrogen, hydrocarbon compound, wherever the number is C2H4, C6H12, regardless of their names, at that moment we are not taking the nomenclature of organic compounds. So regardless of their names, here the hydrocarbons in existence of oxygen and heat, they are burned up, combustion, giving the same thing in all cases: CO2, carbon dioxide and water, carbon dioxide and water. So whenever you have a hydrocarbon plus oxygen in presence of heat, you know that it will give carbon dioxide and water. This is combustion reaction. And lastly, now I'm recording the video without the tripod, that's why you will find a little bit it's moving. Single displacement. And single displacement, here you will have the table of reactivity in the exam, where the elements at the top is more reactive than the elements at the bottom. What this mean, miss? This means that the elements at the top will replace the elements that below. Clear? So here, let's say, as I told you, the hydrogen, the water, you write it as HOH. Okay, so this means that the zinc will replace the hydrogen, but just a moment, go double check if the zinc is more reactive or less reactive than hydrogen. Zinc is below hydrogen, so it is less reactive. So as it is less reactive in hydrogen than hydrogen, it cannot replace or displace the hydrogen. It cannot push it and just take its place, so no reaction. In the other case, here we have gold and HCl. Also, here we wanted to see if the gold is more or less reactive than hydrogen, and yeah, it is above hydrogen, so it is more reactive, so it is stronger, so it will take its place and it will be gold chloride. Okay, and before or number 4, lastly is the, I will explain what is this, but before I explain the whole thing, I want you to focus on the last 2 types of chemical reactions, which they are the, let's wait till the focus become clear. I think it's not clear, okay, because my hand is moving. Okay, here, the synthesis and the decomposition. As I told you, the good news that they are opposite to each other. Here, the simplest thing you will find that there is a compound of two elements and broken down to the simplest components of it. So it is decomposition, or can be the opposite, like two pure elements combine and bind to each other to form a compound. And here we have 1, 2, 3, 4. 1, 2, 3, 4 cases where you have to memorize them, which mainly 3 of them are metal, or 2 of them are metal oxide. Here, when you have a metal carbonate, and here the X represent any metal which is existed before the zigzag line in the periodic table, any metal carbonate is decomposed or broken down into what? Metal carbonate into metal oxide and carbon dioxide. When it is broken down, it is decomposition. When you have a metal oxide plus carbon dioxide in the reactant side, so it is synthesis, the opposite. Here, metal chlorate is broken down into metal chloride and oxygen, decomposition, or they may combine giving the same thing, metal chlorate, which will be in this case synthesis. And here please take care, I'm here because I'm summarizing it for you, but in the exam normally what happened, you will find if it is synthesis, so you will find that side, it will be here the products. Here in case of decomposition, they are the reactants in the synthesis reactions. Okay, and back here, once you find any compound that have OH or hydroxide, this means that it is what? Base. Metal and hydroxide, it is a base. So when a base is decomposed, it will give you a metal oxide and water. If it is acid, which is hydrogen, non-metal and oxygen, it will be decomposed to non-metal oxide and water. At the same thing, non-metal oxide and water, non-metal oxide and water will be synthesis, bind to each other to forming the acid. And that's it. Those are the types of chemical reactions we have. The last thing we will have to practice in the class, which is the converting between the word to the formula chemical equations. And here this a visual map of our lessons for this final exam. As you know, we took the chemical formulas and names. Here are the common polyatomic ions you have to memorize with the oxidation numbers. And here the prefix system that you will use it in case the prefix system, if they are covalent compound, if they are both of them are non-metal, if both of them are after the zigzag line here. And also we have the indicators and symbols of chemical reactions, how you indicate that there is a chemical reaction. Go to page 253 and 258 to memorize those two things. The simplest thing we have, like if a color change, if evolving of gas, precipitation, releasing of heat, if you can remember, and the symbols you have, like if it is one arrow, double arrow, if there is a triangle, if there is a catalyst, and so on. In those 2 pages you'll find them. Balancing, please don't forget the law of conservation of mass, as we have to follow it to say that the same number of atoms have to be on both sides, reactants and products, as mass or matter neither created nor destroyed. And here, as I said before, please don't confuse. You are changing the coefficients and not the subscripts. Here, let me show you one of this one. As we said here, in balancing, you are changing the coefficients, the number beside the compound, and not the subscript. The subscript, you are changing the material itself, the compound itself. Okay? And here the types of chemical reactions, as we said, no reaction if it is less, there is if it is higher in reactivity, referring to the reactivity table, And here I'm memorizing you that you have to write the oxidation numbers at the top: +1, +2, skip transition elements, then +3, skip group 14, and then -3, -2, -1, and 0. For the transition element, the question will give you the element in a Roman number that you have to convert it to oxidation number, which is assured all metals are cations, positive ions, as they are losing elements. So if it is Roman number 1, this means that the oxidation number is +1, Roman number 2, so the oxidation number is +2, +3, etc. Okay, again, this is not a substitute to your notes and textbook, okay, but this map is like summarizing the whole thing, most of it. Okay, as we agreed, I'm expecting from you to revise this video before Sunday. So on Sunday we have our oral quiz, so you have another better chance to improve your marks. Have a rest, nice weekend, and see you on Sunday. Bye.